Astronomers were excited to discover the interstellar object last year. It was named Oumuamua.
Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Oumuamua has resurfaced, sparking chaos at NASA as scientists predict its collision with Earth in just 2 weeks. This massive space object evokes memories of the extinction event that wiped out the dinosaurs. Researchers are scrambling to find a solution to this looming catastrophe, working tirelessly to assess the potential impact. The predicted collision's severity and Oumuamua's origins are under intense scrutiny. Join us as we delve into the urgent warning from scientists, revealing Oumuamua's approaching impact with Earth and the race against time to prevent it. The big comeback of Oumuamua. Oumuamua has suddenly appeared again in our solar system, without any warning or indication after its disappearance from sight 7 years ago. This re-emergence has created a sense of panic and chaos, as no one could predict that it is coming again to threaten our planet. Could this be the beginning of the end of humanity, or is there still hope for survival? With this sudden appearance, scientists have again been on guard, doing all they can to stop this great havoc that will befall Earth from happening, even though they still find it difficult to understand what is really happening. By gathering scientific clues about the object and its origins, they are left to wonder with a series of questions about the alien world. What if Oumuamua is actually an alien probe that was sent to study Earth and its inhabitants? Are the aliens trying to make contact with humans, or do they just want to have control of the whole Earth by first destroying it? If so, what influence are they trying to project on our planet and in society? How are we going to be saved from this calamity? These and many more have been the questions that are adding extra layers of mystery and curiosity to the scenario. Ever since Oumuamua's first shot at our system, scientists have assigned a high value to interstellar objects, which represent material ejected from other solar systems. In this case, Oumuamua demonstrated that the velocity of interstellar objects, which means that they are likely to remain undetected until they are close to the inner edge of the main asteroid belt, is hyperbolic. This hyperbolic flight made it possible for Oumuamua to move around our sun and become unreachable shortly after it was detected. The positioning of the intercept mission directly affects the spacecraft's ability to deploy and reach the target interstellar object, Oumuamua. However, by obtaining samples and studying them up close, astronomers were able to learn much about the formation of other stars and planets without actually sending missions there. From this, a lot was learned about the interstellar medium ISM, including how organic material and the building blocks of life are distributed throughout the galaxy. But what are the specific details that have first been recorded upon this strange object's first discovery? What is Oumuamua, and how was it dealt with before it disappeared? In revealing the long-time secret of the interstellar objects that are on mission towards Earth, Oumuamua becomes the first confirmed object to visit the Earth's solar system. This interstellar interloper appears to be a rocky, cigar-shaped object that somehow looks reddish in color. Therefore, it was named Oumuamua by its discoverers, which means a messenger from afar arriving first in Hawaiian. Upon discovery, Oumuamua is up to 1/4 mile, equivalent to 400 meters long and highly elongated, perhaps 10 times as long as it is wide. The ratio is greater than that of any asteroid or comet observed in our solar system to date. However, while its long shape is quite surprising, unlike other objects seen in our solar system, it provides new clues into how other solar systems were formed. According to observations through the appearance of Oumuamua, it is suggested that this unusual object had been wandering through the Milky Way without being attached to any star system for hundreds of millions of years before its chance encounter with our star system. But immediately after its discovery in 2017, telescopes around the world, including ESO's Very Large Telescope in Chile, were called into action to measure the object's orbit, brightness, and color. This is because the urgency of viewing from ground-based telescopes was vital to getting the best data. MORESO, while combining the images from the faint object camera and spectrograph, 4's instrument on the European Southern Observatory telescope using 4 different filters with those of other large telescopes, a team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii found that Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. Interestingly, no known asteroid or comet from our solar system varies so widely in brightness, with such a large ratio between length and width. Hence, the most elongated objects we have seen to date are no more than 3 times longer than they are wide. With these properties, it is therefore suggested that Oumuamua is dense, composed of rock and possibly metals, has no water or ice, and that its surface was reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years. Consequently, on further research, a few large ground-based telescopes continued to track the fading object as it receded from our planet. 2 of NASA's space telescopes, Hubble and Spitzer, tracked the object, which traveled about 85,700 miles per hour relative to the Sun. Its outbound path is about 20 degrees above the plane of planets that orbit the Sun. Checking Oumuamua's trajectory around the solar system, it is recorded according to the scientists' report that Oumuamua passed Mars's orbit around November 1st and also Jupiter's orbit in May of 2018. It travels beyond Saturn's orbit in January 2019, and as it leaves our solar system, Oumuamua heads for the constellation Pegasus. Other preliminary orbital calculations have also suggested that the object came from the approximate direction of the bright star Vega in the northern constellation of Lyra. However, it took so long for the interstellar object to make the journey, even at the speed of about 59,000 miles per hour, that Vega was not in that position when the Oumuamua was there about 300,000 years ago. Astronomers then estimate that an interstellar object similar to Oumuamua passes through the inner solar system about once per year, but they are faint and hard to spot, and have been missed until now. It is only recently that survey telescopes, such as Pan-STARRS 1, are powerful enough to have a chance to discover them. Interestingly, the bizarre and mysterious object is gradually moving freely into our solar system from interstellar space while still puzzling scientists with its bizarre shape and unknown origins. But how was this interstellar visitor found, and what was it really made of? The shocking space discovery. Oumuamua was discovered by Robert Warwick on October 19, 2017, using the Pan-STARRS telescope at Haleakala Observatory in Hawaii. The discovery occurred approximately 40 days after it passed its closest point to the Sun on September 9th. Upon this discovery, it was formally designated with the name 1I 2017 U1. When it was first observed, it was about 33 million kilometers from Earth, which is about 85 times as far away as the Moon and already heading away from the Sun. Oumuamua turns out to be a small object estimated to be between 100 and 1,000 meters long, with its width and thickness both estimated between 35 and 167 meters. It has a red color, like objects in the outer solar system. However, despite its close approach to the Sun, it showed no signs of having a coma around comets, which forms when they pass near the Sun. Further, it exhibited non-gravitational acceleration, potentially due to outgassing or a push from solar radiation pressure. It has a rotation rate similar to that of solar system asteroids, but many valid models permit it to be unusually more elongated than all but a few other natural bodies observed in the solar system. Oumuamua, thereby, would be remarkable for its extrasolar origin, high speciousness, and observed acceleration without an apparent coma. By July 2019, most astronomers concluded that it was a natural object, but its exact characterization is contentious, given the limited observation window. While an unconsolidated object like a rubble pile would require Oumuamua to be of a density similar to rocky asteroids, a small amount of internal strength similar to icy comets would allow it to have a relatively low density. With the sudden emergence and discovery of this strange and terrifying object, it definitely should have been where it is coming from. Are there traceable indications to its origin at all? Let's find out in the next section. Where is this mysterious object from? Accounting for Vega's proper motion, it would have taken Oumuamua 600,000 years to reach the solar system from Vega. But as a nearby star, Vega was not in the same part of the sky at that time. Astronomers calculate that 100 years ago, the object was 83.9 billion kilometers away from the Sun and travels at 26.33 kilometers per second with respect to the Sun. This interstellar speed is very close to the mean motion of material in the Milky Way in the neighborhood of the Sun, also known as the local standard of rest, LSR, and especially close to the mean motion of a relatively close group of red dwarf stars. This velocity profile also indicates an extrasolar origin, but appears to rule out the closest dozen stars. In actual fact, the closeness of Oumuamua's velocity to the local standard of rest might mean that it has circulated the Milky Way several times, and thus may have originated from an entirely different part of the galaxy. In any case, it is unknown how long the object has been traveling among the stars. The solar system is likely the first planetary system Oumuamua has closely encountered, since being ejected from its birth star system, potentially several billion years ago. It has been speculated that the object may have been ejected from a stellar system in one of the local kinematic associations of young stars, specifically Carina or Columba, within a range of about 100 parsecs, 45 million years ago. The Carina and Columba associations are now very far in the sky from the Lyra constellation, the direction from which Oumuamua came when it entered the solar system. Others have thereby speculated that it was ejected from a white dwarf system, and that its volatiles were lost when its parent star became a red giant. More so, for about 1.3 million years ago, the object may have passed within a distance of 0.16 parsecs to the nearby star TYC 4742-10271. But then, its velocity is too high to have originated from that star system, and it probably just passed through the system's Oort cloud at a relative speed of about 34,000 miles per hour. However, in May 2020, it was proposed that the object was the first observed member of a class of small H2 ice-rich bodies that form at temperatures near 3K in the cores of giant molecular clouds. The non-gravitational acceleration and high aspect ratio shape of Oumuamua might be explainable on this basis. As a result, it was later calculated that hydrogen icebergs could not survive their journey through interstellar space. Interestingly, its origin remains unknown. But what about its size and shape? What is it composed of, and what does it look like? What makes Oumuamua unique among other space objects? According to a report on October 25, 2017, spectra from the Hale telescope showed a red color resembling comet nuclei or trojans. Higher signal-to-noise spectra were recorded at 4.2 meters. The William Herschel telescope on that day showed that the object was featureless and colored red like Kuiper belt objects. Spectra obtained with the 8.2-meter, very large telescope the following night showed that behavior continued into near-infrared wavelengths. Its spectrum is similar to that of D-type asteroids. The large variations on the light curves indicate that Oumuamua may be anything from a highly elongated cigar-like object, comparable to or greater than the most elongated solar system objects, to an extremely flat object, a pancake or oblate spheroid. However, the size and shape have not been directly observed, as Oumuamua appears as nothing more than a point source of light, even in the most powerful telescopes. Neither its albedo nor its triaxial ellipsoid shape is known. If it is cigar-shaped, the longest to shortest axis ratio could be 5.1 or greater. Assuming an albedo of 10%, which is slightly higher than typical for D-type asteroids and a 6.1 ratio, Oumuamua has dimensions of approximately 100 to 1,000 meters long and 35 to 167 meters wide, with an average diameter of about 110 meters. According to astronomer David Jewett, the object is physically unremarkable except for its highly elongated shape. Bannister et al. Have suggested that it could also be a contact binary, although this may not be compatible with its rapid rotation. One speculation regarding its shape is also that it is a result of a violent event, such as a collision or stellar explosion, that caused its ejection from its system of origin. JPL News reported that Oumuamua is up to 400 meters long and highly elongated, perhaps 10 times as long as it is wide. Moreso, a 2019 paper, finds the best models as either a cigar shape, 1.8 aspect ratio, or disc shape, 1.6 aspect ratio, with the disc being more likely since its rotation does not require a specific orientation to see the range of brightnesses observed. According to Monte Carlo, he based his simulations on the available orbit determination, suggesting that the equatorial obliquity of Oumuamua could be about 93 degrees if it has a very prolate or cigar-like shape, or close to 16 degrees if it is very oblate or disc-like. Another paper found in 2021 stated that the extreme shape was likely a result of recent evaporation, and that when the object entered the solar system, it likely had an unremarkable 2.1 aspect ratio. The authors calculated that a month after perihelion, Oumuamua had lost 92% of the mass it had upon entering the solar system. Light curve observations also suggest the object may be composed of dense, metal-rich rock that has been reddened by millions of years of exposure to cosmic rays. Therefore, it is thought that its surface contains tholins, which are irradiated organic compounds that are more common in objects in the outer solar system and can help determine the age of the surface. This possibility is inferred from spectroscopic characterization and its reddish color, as well as from the expected effects of interstellar radiation. However, despite the lack of any cometary coma, when it approaches the Sun, it may still contain internal ice, hidden by an insulating mantle produced by long-term cosmic ray exposure. In November 2019, some astronomers noted that Oumuamua may be a cosmic dust bunny due to its very lightweight and fluffy conglomerate of dust and ice grains. Likewise, in August 2020, astronomers reported that Oumuamua is not likely to have been composed of frozen hydrogen, which had been proposed earlier. The compositional nature of the object continues to be unknown. Looking at how Oumuamua has positioned itself for a strike around the Sun, it is obvious that it is ready to strike the Earth. Let's have a look at its flight positions. Oumuamua strange trajectory. Oumuamua's path seems so different. According to a NASA animation, it describes how the object's path was hyperbolic, meaning it was captured to have moved toward the Sun fast enough as the Sun's gravity could bend Oumuamua's path only slightly, so it was not captured in a looping orbit. Based on observations spanning 80 days, Oumuamua's orbital eccentricity is 1.20, which happens to be the highest ever observed until 2I Borisov was discovered in August 2019. An eccentricity exceeding 1.0 means an object exceeds the Sun's escape velocity, which is not bound to the solar system and may escape to interstellar space. While an eccentricity slightly above 1.0 can be obtained by encounters with planets, as happened with the previous record holder, C1980E1, Oumuamua's eccentricity is so high that it could not have been obtained through an encounter with any of the planets in the solar system. Even undiscovered planets in the solar system cannot account for Oumuamua's trajectory or boost its speed to the observed value. For these reasons, it can only be of interstellar origin. As a result of these, Oumuamua entered the solar system from the north of the ecliptic. The pull of the Sun's gravity caused it to speed up until it reached its maximum speed of 196,200 miles per hour as it passed south of the ecliptic on September 6th, where the Sun's gravity bent its orbit in a sharp turn northward at its closest approach called perihelion on September 9th, at a distance of 0.255 astronomical units, equivalent to 38,100,000 kilometers from the Sun. That is about 17% closer than Mercury's closest approach to the Sun. It is now heading away from the Sun, toward Pegasus, toward a vanishing point 66 degrees from the direction of its approach. Also, on the outward leg of its journey through the solar system, Oumuamua passed beyond the orbit of Earth on October 14th, with a closest approach distance of approximately 0.16175 astronomical units, equivalent to 24,197,000 kilometers from Earth. On October 16th, it moved back north of the ecliptic plane and passed beyond the orbit of Mars on November 1st, and then passed beyond Jupiter's orbit in May 2018, beyond Saturn's orbit in January 2019, and beyond Neptune's in 2022. As it leaves the solar system, it will have approximately a right ascension of 23 degrees and a declination of 24 degrees in Pegasus. It will continue to slow down until it reaches a speed of 58,900 miles per hour relative to the Sun, the same speed it had before its approach to the solar system. What are the proposed theories on this strange object named Oumuamua to get to what it really is? What have NASA scientists said about Oumuamua? According to an explanation to discover the origin of Oumuamua, it is noted that the release of nitrogen ice N2 gas could explain why no outgassing was detected. In this sense, nitrogen ice, equivalent to the size of Oumuamua, could survive for 500 million years in the interstellar medium and would reflect 2/3 of the Sun's light. As a result, this explanation was further supported in March 2021 when scientists presented a theory based on nitrogen ice and further concluded that Oumuamua may be a piece of an exoplanet similar to the dwarf planet Pluto, an exo-Pluto as noted from beyond our solar system. However, this theory has been criticized by Loeb. In November 2021, theoretical studies by Siraj and Loeb hypothesized that Oumuamua was not a nitrogen iceberg. 2023, it was proposed that the observed non-gravitational acceleration and spectrum of Oumuamua can be best explained by hydrogen outgassing from the water ice matrix. The buildup of hydrogen in the water ice is expected to happen in interstellar comets due to low-temperature water ice radiolysis by cosmic ray particles, while Oumuamua or similar cometary bodies were in interstellar space. In hydrogen ice theory, it has been proposed that Oumuamua contains a significant amount of hydrogen ice. This would point to it originating from the core of an interstellar molecular cloud, where conditions for the formation of this material might exist. However, the sun's heat would cause the hydrogen to sublime, which would in turn propel the body. Proposed that the hydrogen coma formed by this process would be difficult to detect with Earth-based telescopes, as the atmosphere blocks those wavelengths. Regular water ice comets undergo this as well, but to a much lesser extent and with a visible coma. This may as well explain the significant non-gravitational acceleration that Oumuamua underwent without showing signs of coma formation. More so, significant mass loss caused by the sublimation would also explain the unusual cigar-like shape, comparable to how a bar of soap becomes more elongated as it is used up. However, it was later shown that hydrogen icebergs cannot form out of small grains, and with that, by not having to evaporate during their journey in interstellar space, they would have had to have been formed about 40 million years ago, in the close vicinity of the solar system. On October 26, 2018, Loeb and his postdoc, Shmuel Bialy, submitted a paper exploring the possibility of Oumuamua being an artificially thin solar sail accelerated by solar radiation pressure in an effort to help explain the object's comet-like non-gravitational acceleration. Hence, the techno-signature theory. Other scientists have also stated that the available evidence is insufficient to consider such a premise and that a tumbling solar sail would not be able to accelerate. In response, Loeb wrote an article detailing 6 anomalous properties of Oumuamua that make it unusual, unlike any comets or asteroids seen before. A subsequent report on observations by the Spitzer Space Telescope set a tight limit on cometary outgassing of any carbon-based molecules and indicated that Oumuamua is at least 10 times shinier than a typical comet. The solar sail technology signature hypothesis is thereby considered unlikely by many experts owing to the availability of simpler explanations that align with the expected characteristics of interstellar asteroids and comets. Moreso, the Initiative for Interstellar Studies, I4Is, launched Project Lyra to assess the feasibility of a mission to Oumuamua. Several options for sending a spacecraft to Oumuamua within a time frame of 5 to 25 years were suggested. In this case, different mission durations and their velocity requirements were explored with respect to the launch date, assuming direct impulsive transfer to the intercept trajectory. The Space Launch System, which is also being looked at for interstellar precursor missions, would be even more capable. Such an interstellar precursor could easily pass by Oumuamua on its way out of the solar system at speeds of 63 kilometers per second. More advanced options of using solar, laser electric, and laser sail propulsion based on breakthrough starshot technology have also been considered. The challenge is to get to the interstellar object in a reasonable amount of time and at a reasonable distance from Earth, and yet be able to gain useful scientific information. To do this, decelerating the spacecraft at Oumuamua would be highly desirable due to the minimal science return from a hypervelocity encounter. Initially, if the investigative craft goes too fast, it will not be able to get into orbit or land on the object and will fly past it. The authors therefore concluded that, although challenging, an encounter mission would be feasible using near-term technology. Seligman and Laughlin then adopt a complementary approach to the Lyra study, but also conclude that such missions, though challenging to mount, are both feasible and scientifically attractive. With observations made within this short period of time, it is believed that Oumuamua was in a hyperbolic orbit, according to the scientists. This boomerang-shaped flight indicated that the rock is not native to our solar system, but was only passing through the Sun's neighborhood and would never be seen again. Other scientists also conclude that, rather than being an asteroid, Oumuamua must be a comet. Comets in the solar system receive additional momentum from the water and dust that evaporate from their icy nuclei as they warm up close to the Sun. These comets, however, are famous for their spectacular tails that light up as a result of the outgassing process, while Oumuamua showed no signs of a tail. Thanks for watching. Remember to like and subscribe to this channel for more updates. While you're still here, make sure to click the video on your screen for more mind-blowing videos.